Hello everyone, and welcome to the practice problems for rates of change and tangent lines. I'm going to real quickly just write in the answers so that those of you that tried the problems on your own and are just quick checking to see if you did them right can know that. The general formula for this one is -2 over a squared. For the next one, the formula is 3x squared minus 3. For the equation of the tangent line at the point 0, 3, it's y is equal to -3 times x minus 0 plus 3. In this case, that format is a little silly, so I am going to just expand that to this. And for the normal line, so you might not have known what the word normal meant, that means perpendicular to the tangent. So I will explain that in the full video. But the answer is y is equal to positive 1/3. So all I did was take the negative reciprocal of the slope, x minus 0 plus 3. And again, that can be written pretty easily in y is equal to mx plus b format. The next answer is y is equal to 1/2 x minus 1 plus 3. If you expanded it, you would have gotten y is equal to 1/2 x plus 5/2. Either answer is acceptable. There's really no reason to do the second one. The answer to this one is -1. The answer for part A is -1 over a squared. For part B is x is equal to 2. And for part C, the tangent gets closer to 0 as A approaches infinity. And finally, number 6, which you might want to skip ahead through the video and watch, there are actually two lines that are tangent and pass through that point. There is one at x is equal to -1, and that equation is y is equal to 2x plus 10. And there's a second one at x is equal to 3, and that equation is y is equal to -6x plus 18. All right, so those are the answers real quick. I am going to go back now and actually go through these problems. If you did them on your own, great job. All the way back, there we go. All right, everybody. So write a general formula for the slope of the line tangent to y is equal to 2 over x for any given point A. So I think you've learned by now that I'd really like you to start with a graph. It gives you a picture of what's happening. So 2 over x is going to have a vertical asymptote at 0. And because this is technically 0x plus 2, 0 over 1 is 0, so it's also going to have a horizontal asymptote at 2. And then you really just need to plot one point. If x is equal to 1, you would get 2. If x is equal to -1, you'd get -2. So it's a very straightforward graph. I missed that point. It's okay. All right. So I want a general formula, so I'm actually just going to make up 2 points. I'm going to make it a little off from that one. I don't want you to think that I'm using that point. I'm just going to use a, comma, 2 over a. That would be the y coordinate if the x coordinate was a. Your second coordinate is always going to be the same, a plus h. And then if h was 0, we would actually have the same 2 points. So unlike the ones we were doing before, this one is awesome to plug into. Look at that. We're done. I don't know if you remember from last class that sometimes getting the y value is in and of itself a problem. But not for these. Don't worry, this one will have a different problem. So the general formula for the slope, so I'm going to call it m. The slope is the limit as h approaches 0 for y2, 2 over a plus h, minus y1, 2 over a, all over x2, a plus h, minus x1, which is a. In other words, I know some of you are sick of hearing me say it, but I really need you to understand this concept. You're finding you really want to know the slope right here, but you can't find the slope at a single point. You need 2 points to use the slope formula. So I'm going to find the slope between those 2 points, which, as you can see, is totally not correct. But if h were 0, then the 2 points would literally be the same 2 points. If h was 0, the 2 points would be a, comma, 2 over a, and a, comma, 2 over a. So I'm going to use the slope formula, and I can't actually let h be 0, but I can take the limit as h approaches 0. So I'm really hopeful that that's making some sense. Okay. What makes this one hard, it was not getting the y value, but it is clearing the complex fraction. So the safest way to do it for most people is to get a common denominator here. So this one needs the a plus h. This one needs the a plus h. This one needs the a. So now we have 2a minus 2a minus h. Biggest error of this section is right there, forgetting to distribute that negative to the h. Oh, and I made a different mistake. I was so excited about telling you about that mistake. Minus 2h all over the new common denominator is a times a plus h. And this denominator is just h. So now I have the limit as h goes to 0 of these cancel. So minus 2h over a times a plus h all over h. So once you have the numerator as a single fraction and the denominator as a single fraction, I can make it into a fraction by writing h over 1. I can flip and multiply. So I think you guys call it keep, change. I'm going to change this from division to multiplication, and flip. I say you guys because that's not how I learned it. We did flip and multiply. All right, so this is gone because I changed it to that instead. And now this is gone because an h in the numerator cancels with an h in the denominator. So now I'm finding the limit of negative 2. I multiply straight across the numerator and straight across the denominator. If you wrote this as a squared plus ah, that's fine. If you just left it as a times the quantity a plus h, that's fine. But now we had to do this process because at this point up here, we couldn't let h be equal to 0. But now we can. When we plug a 0 in right here, we're going to just get negative 2 over a squared. And that's the answer. In case you've lost sight of what we've done, what we did was we found a formula for the slope. So meaning instead of finding the slope at a very specific point, we found a formula, and now you could find the slope anywhere. So if I said, what's the slope at 1, 2, 3, 4, 5, I'm expecting it to be a negative shallow number. And sure enough, at a is equal to negative 5, the slope is negative 2 over 25. It's negative and it's very shallow. But if I want to know the slope here at 1, it's still negative, but it should be a lot bigger. Let's try that. At a is equal to 1, oh, actually that's a positive 5 up there. At a is equal to 1, the slope is equal to negative 2 over 1, which is negative 2. So that makes a lot of sense that the slope is negative 2 up there. You'll notice that the slope is always going to be negative. Look at that. It's always negative. Never a positive slope. And look at the equation. negative 2 over a squared. A squared is going to be positive. So negative 2 divided by a positive number is always going to be negative. So hopefully that's making a lot of sense to you. All right, so this one was in the practice set because of the complex fraction. This one is in the practice set because it has a cube. Pretty much it's just awful. It's here to torture you. I really can't tell you anything else about it. We are going to start with a graph like usual. But I don't really know what the cubic function looks like. I mean, I know its general shape and I know it goes through that point, but I can't factor that. So I'm going to give it just a little graph only for the sake of showing you my 2 points. I really don't know what the graph looks like. I'm going to put big question marks. Okay? This is just a general shape. Chances are good that it's wrong. But this point is the point A. Actually, I see now they wanted to know at the point xy. So I'm going to write it as x. Little change now. And x cubed minus 3x plus 3. That would be my first point. My second point, it's always the same, but we're gonna wean you off of using the letter A and just skip straight to x. X plus h. These two would be the identical point if h was 0, but h isn't 0. So x plus h cubed minus 3 times x plus h plus 3. Okay. So some of you are going to have to multiply x plus h out 3 times. Have fun with that. I hope that goes well for you. It's pretty long. But anybody that actually liked Pascal's triangle back in pre-calc might remember that when you have a cubic, the shortcut is to say it's going to go x cubed, then x squared, then x, then no x's. No h, 1h, 2h, 3h. Is this coming back to you at all? And the coefficients for the cubic one is 1, 3, 3, 1. That is definitely faster than multiplying out x plus h 3 times. But if you don't remember your pre-calc, don't tell me. I don't want to know if you don't remember your pre-calc. All right, so I'm going to expand this to x cubed plus 3x squared h plus 3xh squared plus h cubed. And I didn't even get to this part yet. Minus, now I'm going to do this part. Okay. 3x minus 3h, another place to go wrong is that minus, distribute the negative, plus 3. And believe it or not, that does not simplify. So we're just going to go from here. I have my blue point and my green point, and we're going to do the limit. The slope is going to be the limit as h approaches 0. If h were 0, this would be gone, this would be gone, this would be gone, this would be gone, this would be gone. And if you look at what's left, it looks just like the green. X cubed minus 3x plus 3. They would be the same point. So we're going to trick it into giving us the same point. I don't actually want to cross those off. So now I'm going to do the blue. I always do the bigger one first as my y2. So there's less places I have to distribute the negative when I do minus y1. Lots of places to go wrong. H cubed minus 3x minus 3h plus 3 minus y1, which is x cubed minus 3x plus 3 all over x plus h minus x. Like I said, I know there's a bunch of you that are just writing h on the bottom. You can do that if you want to. But I like to see it as y2 minus y1 over x2 minus x1. It helps me. Okay. So I'm just going to go ahead and distribute that negative. I'm not going to, it's too long a problem to write all the way out. So I'm just going to distribute it like that. And now I'm going to cancel out what I can. So the x cubes cancel, the 3x's cancel, and the 3's cancel. I am left with everything else in blue, and I'm going to also skip another step, I'm trying to save myself a little time here, and factor out the h. You're always going to factor out the h, so you might as well get used to that. This one is still going to have an h left, and this one's going to have 2 h's left, and this one's going to have a -3 left when I factor out the h. And on the bottom, this x cancels with this x, and I'm left with just an h on the bottom. So why did we do all that simplification? Because we wanted to take the limit as h approaches 0, but if h is 0, you're going to get a 0 in the denominator, which you can't have. But because you simplified, now you can cancel out the h's, and now you can let h be 0. What do you get when you plug in a 0 here? Well, there's no h here, so you still have a 3x squared. There's an h here, so this whole term is going to become 0. And this is going to become 0, and you're left with a -3. That is a formula for the slope of the line tangent to the curve at any point. Okay, so we actually could make a pretty nice general graph from this. So we already knew this point at 0, 3. We know that's a point. What's the slope there? At x is equal to 0, the slope is -3. Whew, look at that. I did draw a negative looking slope. And then at x is equal to 1, the slope is 3 times 1 minus 3 is 0. So I still don't know where 1 would be. I mean, I could find out by plugging it into here, but I know now that it's going to dip down at 1. And then at x is equal to 2, I don't really need to know the slope exactly. At 2, it's going to start to be some kind of positive number. So I know that it does this. Can you think about the other time when the slope is 0? At x is equal to -1, because -1 squared is still 1 times 3 is 0. So at -1, that's where it's going to make its other turn. We found the two places where the slope is 0, which is kind of nice for making a general graph. Okay, I swear I did not know that graph ahead of time. Maybe my subconscious from years of teaching it, but haven't seen this problem since last September. So cubic general shape, but now using this formula, you were able to make a pretty nice graph, which was so much easier than plugging numbers into the original and actually plotting points. You could tell where the graph was going to turn by knowing where the slope was positive and where the slope was negative, which is going to be a key to what we do in the future. On the next page, it asks you, not the next page, the next part of this question says, write the equation for the line tangent to the curve. So I'm going to redraw. Actually, I'm going to take these answers off there from when I was just showing answers. So what it's saying is at the point 0, 3, remember we just kind of made a rough sketch of this a second ago. So they're saying, what would the equation of the line tangent be right there? What is that line? And then it says line normal. Normal means perpendicular to the tangent. So sometimes you need to know a different angle, the perpendicular angle. I would be lying if I said I completely understood it, but I know that in physics and in my husband's job as a dam engineer, they definitely look at normal forces because they have a dam and they want it, the water is coming in perpendicular a lot of times to this thing or at a different angle, and so normal is important to them. But I'd be lying if I said I knew exactly how it worked. So we'll erase that. And hope he doesn't watch this video and be embarrassed. All right, so tangent. So whenever it says write the equation of the line, you need two things to write the equation of a line. I'm going to harp on this because we will write equations of the lines all the way through May. Two things are needed to write the equation of a line: point and slope. If they give you the point, you're golden. You're halfway there. Y is equal to x minus 0 plus 3. Now all you need to know is that slope. What is the slope of that blue line? Well, you figured out a formula a minute ago. The formula for the slope at any point on the curve is 3x squared minus 3. It's on the previous page. That's what we found. Should be on your paper. So at x is equal to 0, that's the point I'm trying to find. The slope is 3 times 0 is 0 minus 3 is minus 3. This is the equation. You do not need to simplify it, even though it's totally easy to simplify because it has a 0 in it. And notice I left very little room. That's because normal, it's still going through the same point. That part of the equation didn't change. Normal just means perpendicular, so now the slope is 1/3. Okay, write an equation for the normal line to the curve f of x is equal to 4 minus x squared at x is equal to 1. So I'm going to say two things. Number one, whenever you see the directions or write an equation for the line, right away you should be doing this. X minus 1 plus something. You need to find the actual point. So when x is 1, you get 3. You are literally halfway done. All you need now is that slope. So let's picture this graph. 4 minus x squared is a downward parabola that's been moved up 4. It has intercepts at 2 and negative 2. If you're trying to make it nice, 1 and 3 is where it goes like that. So at x is equal to 1, it has a tangent line. A tangent line would look like this. It would just barely skim the point. The normal line is just perpendicular to the tangent. So the normal line is going to be this one. So now you need to practice finding the equation for how to find the slope at any point. So we're going to go through another one. So we need 2 points. We need any 2 points. I'm going to pick them over here just because I have something else going on over here. So the point is x and 4 minus x squared. Hopefully you're getting the hang of this. The second one is x plus h, comma, 4 minus x plus h squared. You need to expand that and then do the limit as h approaches 0 of 4 minus x plus h squared minus 4 minus x squared all over x plus h minus x. So hopefully you can see how awful it is not to expand this. You really don't want to do that like that. At least I don't. I think that this is really tricky to work with. So I always take the time to expand it over here by my point. So x plus h, 4 minus x squared plus 2xh plus h squared. I know it's getting a little hard to see. I'm going to move it down. X plus h, comma, 4 minus x squared minus 2xh minus h squared. That's what I would write in here. 4 minus x squared minus 2xh minus h squared. You will be better off if you do that over on your graph. So this is equal to the limit as h approaches 0. I usually cross this off and distribute my negative. And then you can cross off things that are the same, the 4 and the 4, the x squared and the x squared. And if you want to save yourself a step, factor out the h. You're always going to factor out the h. Minus 2x minus h. All over on the bottom is just h. Those cancel. And when h is 0, you get negative 2x. Remember, this is a formula for the slope at any point. But what point do we need it for? At x is equal to 1, the slope is negative 2. But that would be the tangent line. The formula for the slope, for the tangent slope, we don't usually write that in the definition, it's understood, but it is the formula for the tangent slope at any point. Your equation is asking for the normal. It is literally a simple extra step. Y is equal to positive 1/2 times x minus 1 plus 3. Okay? So that's your final answer. That is the equation for the line normal to the curve. And we should quick look at it. So it does go at negative or positive 1, 3. And yeah, it looks like it's positive and going up about up 1 over 2. I feel really good about that answer. I really cannot stress enough that if you get an answer wrong and you haven't taken the time to graph it, your partial credit will be very small for me. You have to learn to make the graph first to see if your answer makes sense. Next one. So this is a perfect example of why we make the graph first. So this is an absolute value graph. It's been moved over 2, and it looks like this. Boom, boom. The question is, what is the slope at x is equal to 1? All right, you ready to be excited? Whenever you have an absolute value graph, you do not need to do this long, awful limit method, right? Oh, that wasn't even on that page. Look at that. Look at all that work. You don't have to do it because absolute value graphs are simple. They just have a slope of negative 1, and then they turn and they have a slope of positive 1. Or if this had a 3 in front of it, they would have had a slope of negative 3 and then a slope of positive 3. So what is the slope at 1? Negative 1. So I can't stress enough. Make the graph. Okay. So this says find the slope of the curve at x is equal to a. So I have no idea why I circled that. That's not tidy. So we're going to start with the graph, just like we always do. By the way, we have done almost this exact same problem. These are just practice problems. So if you want to pause, try and do this one on your own, and then come back, that would be terrific. That is definitely what I would be doing if I were in class. But you have homework ones to practice on, so I'm going to keep showing them to you on the videos. It is a straight up hyperbolic function. It is actually the parent hyperbola. So it looks like this, and then like this. Has asymptotes at x is equal to 0 and y is equal to 0. And we're going to find the general formula. When it says find the slope, it's saying the general formula that you could use. So any point. They've gone back to a. That's fine. You need to be flexible. So this is a comma 1 over a. The second point is always the same. whatever it is, plus h, and then 1 over a plus h. So this is our second opportunity to practice doing a complex fraction. I'm going to do the limit as h goes to 0, because if h was 0, they would be the same point, of y2 minus y1 all over x2 minus x1. Rewrite your limit. Don't be sloppy. The bottom is always easy. H. Although we are going to be dealing with complex fractions, I'm going to change it to h over 1. I'm going to make the top one a combined fraction. So this one needs an a on the top and the bottom. This one needs an a plus h on the top and the bottom. And that's what gives you your common denominator. They both have the denominator a times a plus h. This numerator is a minus this numerator is a plus h, but that negative gets distributed to both of them. So does the 1, but you can't really see it. Minus a minus h. This is where people are going to go wrong. Watch out. So this becomes, don't forget to rewrite the word limit. I'm going to be looking for that. Negative h over a times a plus h over h over 1. Keep, change from division to multiplication, and flip. Or just flip and multiply. So this is gone, and this is gone because we changed it. I can multiply straight across the top and straight across the bottom, but these h's are going to cancel. So now I'm going to have the limit as h approaches 0 of straight across the top would give me negative 1, and straight across the bottom will give me a squared plus ah. All right, we're finally ready to plug in h is equal to 0. We couldn't plug in h is equal to 0 back here because it would have given us a 0 in the denominator. We can plug a 0 into here, and we get that the slope is negative 1 over a squared. This is the answer to part A. Find the slope of the curve at x is equal to a. So if you know where you want the slope, that's how you can find it. So now they're going to say, where does the slope equal negative 1/4? So for part B on this equation, they're saying, when is the slope equal to negative 1/4? Now, I could actually solve this equation, but honestly, it's you can probably just do it in your head. At a is equal to 2. Because negative 1/4 would be negative 1/4. A would have to be 2. But for the sake of argument, let's say that you didn't know how to solve it. Just by looking at it, if that wasn't obvious to you, you could clear your fractions, multiply both sides by 4a squared. Multiplying through by all the denominators always works. On this side, the 4's cancel, and you get negative a squared is equal to negative 4. A squared is equal to 4. A is equal to, ooh, maybe it's good that we did that. Look at that, plus or minus 2. All right, so let's look at our graph. Let's think about that. So at 2, there's 2, the slope is negative 1/4, and at negative 2, the slope is negative 1/4. Ah, look at me, I forgot the plus or minus. Shame on me. So that's the answer to part B. Part C, what happens to the tangent to the curve at the point a comma 1 over a for different values of a? So we talked about this a few problems ago, how as you get a gets bigger and bigger and bigger, this slope is going to become 0. You can tell that the slope is flattening out, and it makes sense in the equation because as a goes to infinity, you're literally going to have 1 over infinity squared, which is pretty much 0. You can't actually let that happen. That's where we get limits from. But it's going to end up being flat. And the fact that you can see that on the graph, and the graph matches the limit, matches the equation that you got, should make you feel really good about how well this worked out. Okay, this next question is super hard, but we're gonna work through it. You can do it. I believe in you. So it says find the equations of all the lines tangent to y is equal to 9 minus x squared that pass through the point 112. So 9 minus x squared. So at 0, we're at 9. And then from there, at 1, we would be at 8. At -1, we would be at 8. At 3, we would be at 0. I'm just trying to make this graph. I made it a little big so that you could see it. I don't know if the other points are going to be perfect, but this is enough for me to graph it. That is not nice. There, that's good. So that passed through the point 112. So here's 112 right there. So try to draw for yourself a line that is tangent to the red parabola, but also goes through the blue point. It's my experience that 9 out of 10 kids draw this one, which is great. There actually is another one. It could be tangent on this side. That wasn't quite tangent. They're really hard to draw. Okay. So you want it to like just barely touch. So there's actually 2 lines that we could draw that could just, it's easier to see this one, that could just barely touch and still go through that point. Our job is to figure out what the equations of those 2 lines are. So here is the beautiful thing. We can already write a good bit of both lines because both of them pass through the point 112. Remember, what 2 things do you need to write the equation of a line? A point and slope. We have the point. We just need to know the slope of that more shallow line and of that steep one. Now, one of these is going to be really steep and negative. I'm expecting to see it come out to be a very steep number, and this one's going to be a little more shallow and it should be positive. So I'm always thinking about my answer ahead of time and trying to decide, what do I think it's going to end up being? Okay, so this point right here is going to be called a, comma, 9 minus a squared. Now, I'm going to do everybody a little favor. We are close to the end of this lesson, and I'm actually going to give you the formula. We're not going to do the limit and the 2 points and the a plus h. We're going to skip that. I'm just going to go straight to the answer. So the formula for the slope at any point xy is -2x. So that's an answer that you would have gotten if you had done that whole big thing with the limits and the x plus h, the a plus h. But we're going to save ourselves 5 minutes and not do that because this problem is already hard enough. So here's what you need to know about this problem, and that is that there are 2 ways to find slope. One is that the slope by the formula is -2a. Think about that. I told you that the formula for the slope was -2x. So at point A, it's actually going to be -2a. But 2, you can still use the 2-point method. Don't forget that. That's still a thing. So we can do 12, I'm going to put it in blue for you, minus, what's the y value there? 9 minus a squared all over 1 minus a. Why would we do that? Because they both tell us the slope. So your 2-point method works and your formula for the slope at a point works. And now you can put those two together and say negative 2a is equal to, what is that going to be? 12 minus 9 is 3 plus a squared over 1 minus a. Okay, so now I have an equation that I can solve. I'm going to clear the fraction. I love to clear fractions. 1 minus a, and that on both sides. 1 minus a. That gives me negative 2a plus 2a squared is equal to, on this side it cancels, 3 plus a squared. I see an a squared in my equation. What do? This is another little mantra that I'd like you to have memorized. Whenever you have an x squared, or in this case an a squared, in an equation, set it equal to 0 and factor. If you don't know that yet, you need to write that down someplace important. Whenever you see an x squared in an equation, set it equal to 0 and factor. I'm not kidding. I could still text my own 2 children today with the first half of that phrase, and they'd be like, Mom, but they'd still say, set it equal to 0 and factor. It's going to come up all year. You got to know it. So I'm going to subtract a squared. I get a squared minus 2a minus 3 is equal to 0. Set it equal to 0 and factor. A plus 1 is equal to 0. So a is either equal to 3 or negative 1. So they're telling you the 2 times when the 2-point method produces the same answer as the formula method that we learned. So a could be 3 or negative 1. Well, according to this point right here, if a is 3, then what would you get from that? 9 minus 3 squared is 0. Ooh, that's right here. 3, 0. So this must be the other one. When a is negative 1, 9 minus negative 1 squared, which is 1, is 8. You just found the 2 points. So some people actually write the 2 answers differently. Some people are going to write the 2 answers x plus 1 plus 8, and y is equal to x minus 3 plus 0. In the end, the 2 blue answers and the 2 green answers will produce the exact same thing, but both of them still need slope. So the question is, how do you find the slope? Again, now that you know the point, you can use the 2-point method. You can do 12 minus 8 over 1 minus a minus 1 is equal to 4 over 2 is equal to 2. The slope is 2 for the negative 1, 8 point. Okay? But that's method number 2. That's method 2. Method 1 says if you know your point, if you know your a, the formula for the slope anywhere on this parabola is just negative 2a. Negative 2a. That was faster. You're going to love our little formula here. So let's do that for this one. So negative 2a is the slope, and that produces negative 6. Which, remember we said we predicted that it was going to be pretty steep? It is pretty steep compared to this one, which is shallow. Now, you can box either one of these answers. They're both acceptable, and they are the same. But just to prove my point, a lot of people look at this and they're like, oh, I like y is equal to mx plus b better. You can change it to y is equal to mx plus b just by multiplying it out. 2x minus 2 plus 12. The answer is 2x plus 10. And unfortunately, sometimes you'll have to do that to check your answer on a worksheet or in the book because they're going to write it that way. But look, this will do the same thing. 2x plus 2 plus 8. Y is equal to 2x plus 10. And that's one of the reasons why books do it. They simplify it so everybody can see the same answer. But this answer is just as valuable. This says to me, this line has a slope of 2 and it passes through the point negative 1,8. Where this one says it has a slope of 2 and passes through the point 112. They're both great. So this was a pretty complicated problem. Great job hanging in there with me. We are done for the day, and I hope you have a great rest of your day.